All right. Hello, everyone. Good afternoon to all in the room, and greetings of the day to everyone joining us digitally for Microsoft Build. Hello. OK, so we are here for the session on event-driven architectures, serverless apps that slay at scale. So we will take you through the journey of slaying at scale. But before that, how many of you here in the room or all online are working on event-driven apps? Oh, wow. That's like about 85% of the room already. So that's great. This is a great session, right audience? So we're going to get cracking. I am Devanshi Joshi. I'm the Senior Product Marketing Manager for Serverless on Azure. And here with me today are a fleet of speakers, two of them from the Coca-Cola Company, Todd Clark and Scott Yee, along with them, Thiago Almeida from Microsoft. We will take you through the scenarios for event-driven apps, then share how Coca-Cola really built their massive scale for their IT ops and flexibility and all of the orchestrations that they need on their everyday programs. And finally, through all of this, take you through whirlwind of demos part by part. Now, let's get started. Traditional architectures often rely on this synchronous communication and tightly coupled experiences for components that have scalability issues and inefficiencies already built in. And these event-driven architectures are reactive, adaptive, and innovative, allowing for you to do easy scaling, bring in that flexibility, and enabling systems to handle that variety of scale that is needed for your evolving architecture. Services can be developed, deployed, and scaled independently in this modular fashion, reacting to those incoming events from different sources, data sources, and bringing it all together in a resilient fashion. All of this processing in real time, ideal for applications that are riding the wave of AI and more. Now, often we struggle with this management of infrastructure as we go to react for this real-time events. And serverless forms that key experience for your application to be truly resilient and reactive in real time. Of course, if you design it with the traditional experiences, it's time-consuming and complex. And the dynamic scalability that comes in with serverless kind of takes it all away. So along with that, giving you cost efficiency, giving you faster time to market, where you're just focusing on your piece of logic to build that event-driven architecture. And additionally, serverless computing is cost efficient. So with that, from Azure, we have, starting at the core, Azure Functions and Azure Container Apps, serverless code and serverless containers, helping you run your app in your desired fashion. Easily integrated with a variety of events coming in, ingestion engines through event sources, event hubs, data stores, blobs, databases, analytics platforms, Microsoft Fabric, AI with AI Foundry, building all your kind of apps for serverless inferencing, building those customized AI agents. And as you build your overall solution architecture, having components with different app types, whether it be PaaS with app service, with Kubernetes in Azure Kubernetes Service, the serverless on Azure landscape supports you all along. Even so, extending it to build with third-party APIs, with Arc, Elasticsearch, other cloud platforms, enabling you to run anything, do everything, and run anywhere. Now, getting into the scenarios in short, we'll start with AI apps and agents, where I touched upon customized agents and building that. What does it really take? We'll take you through that experience. We'll also go deeper on each of these eight scenarios. So kind of sum it up in a very logical scenario for a demo on how each of this experience lights up for your event-driven architecture, right from workflow orchestrations, microservices, backends of web and mobile APIs, and of course, the regular bits of reliable messaging, scheduled tasks, responding to changes in files and databases. But before that, let's actually invite Coca-Cola I would like to have Scott Yee join me on stage to take us through how did they build their internal IT solutions for that massive scale, lighting up these variety of event-driven solution scenarios we just covered. Over to you, Scott.
Hello, everyone. My name is Scott Yee, and I'm the head of engineering in Coca-Cola North America. The Coca-Cola Company has 200 brands in over 200 countries, and we have over 200 bottling partners and millions of customers. And you can imagine we have a lot of integrations with all these partners. We recently celebrated our 139 year anniversary. And over the years, we've bought a lot of integration tools. And we couldn't, while a lot of them are great, we couldn't get it to work the way we needed to. As we had a really diverse set of applications, ranging from mainframes to virtual machines to freestyle machines to external SaaSes and, of course, cloud native. We needed a solution that is able to meet all this diverse set of applications, and also that it's scalable, maintainable, economical, and easily configurable. And with that, I'm going to hand it over to my colleague, Todd Clark, who will tell you more about this firm middleware that we built to meet this need. Todd?
Hi, thanks. Okay, so the agenda I'll present, right, is I'm going to talk about what's in integration, and I want you to remember it's how applications connect. I'm going to talk about scalability, and I hope you walk away thinking that scalability is just more than numbers and throughput. And then a challenge to scalability that kind of made us think this way. And what I hope you remember is Conway's Law and business scalability and the ability to adapt quickly is important. And then how do we overcome this challenge? Well, we stacked all the right pieces together. So when you stack the right parts of your stack, you can gain leverage. And what are those parts? We built our own integration platform. We call it Firm. And I hope you remember that consistency will help you to enable business scalability. The next layer of that is a Firm facilitator app that we created in ARM templates. And I want you to remember ARM templates are awesome because you can point and click and export them, and then that lets you worry about building generators and doing things at scale, right? And lastly, we wrote a MuleSoft translator app. And I hope you walk away realizing if you have a really large end-of-life project, write translators, write transpilers. They're going to save you a lot of money if you do that. And also that Microsoft's been a great partner. We couldn't have done this without their tremendous support. So we'll start with what's an integration. If you look here on the far right-hand slide, I give 3 examples. One is a search outlet API that is for our MyCoke B2B system. If a store manager knows their outlet ID, well, then they prove that they know it, and we let them sign up, and we let them buy stuff online, right? Another example is marketing data accruals, right? We get those from SAP. They go to a marketing tool. They let our marketing team know, well, how much credit do I have with various agencies? A third example is eB2B systems and CokeNet, which is for Latin America. Well, they get orders. Those orders go to all the right bottlers. The right bottlers fulfill those orders. So some traditional tools, TIBCO, MuleSoft, WebMethods, CPI, right? Scott mentioned those. We bought a lot of them. They didn't work great for us, right? So what's to remember here? What's an integration? When I speak of it, it's a small bespoke application. It contains some transformations, some business logic. They make 2 or more systems work together. So scalability. You can't talk about scalability without talking about the numbers. This integration platform that we've built, every time an integration runs, it writes a log of that to a MySQL transaction table, which links to a dev log. Those are some numbers. Peak rates are in the low thousands per second. In 2016, if you built a stable system with these kind of numbers, you would have said, wow, that's great, we did that, it's stable, right? But I think with cloud and Azure Functions, this is kind of table stakes. So I'm going to throw out there the idea that, hey, maybe we should redefine what scalability means. And this is a challenge that we face that points this out. So in 2023, we had a version of MuleSoft that's going end of life. We wrote something to scan all our MuleSoft integrations, and we found out we had 126 bespoke integrations. We realized that we had less than 200 working days to replace 126 integrations, so less than 2 days per each to get to prod. And we landed with a 2-person support team and a 5x cost reduction. Right? And you may say, well, hey, this is kind of a once every so many years occurrence. Well, I would say that at Coke, making a massive change like this really quickly is just normal course of business. And there's some things that come together that make that happen. Our franchising model, we have hundreds of bottlers putting our beverages within arm's reach of desire, right? We have an org structure with many software product owners. And if you know Conway's Law says that your IT systems are going to be a copy of your company's communication structure. So when the company reorganizes, when it changes, when the bottlers change, right, we need to make a lot of changes very fast, right? So scalability is no longer just about throughput, it's about how fast can we adapt. So how do we overcome this challenge? We stacked some things together. At the bottom, for reliability, we have Azure services. On top of that is stacked our firm integration platform. Above that is ARM templates and a firm facilitator wizard. Above that is a MuleSoft translator app, right? So I'm going to go through each of these, right? So I'll come back to the same 3 examples of integrations, and we'll talk about what's the architecture of firm framework and explain that. So at the beginning here, the first integration I have listed is searching for outlets in MyCoke. Well, it's an APIM connected to an Azure function with SOSQL, right? Calling into Salesforce. The next one, it's SAP getting iDocs and Logic Apps to blob storage to a service bus through an Azure function, right? To the marketing tool. And then, the next one, you can see the flow there for, the bottlers kind of come and they fetch, right? Daily, all the orders that are for them. So, there's hundreds more like this. And architecturally, how does this fit in with Firm? Well, there's a set of shared resources, a web app, a MySQL, blob storage, Redis, right, that they all share. And well, what happens is you can see, if you look on the kind of the right-hand side, you can see some screenshots of a Firm console, and you see that there's transaction tracking and analysis and metrics. People can retry the Azure function. The Firm web app will cause other Azure functions to be retried automatically that have been missed or failed, right? You always want to build a retry mechanism where your developers don't have to do it. It's built in. Right? So the next thing to talk about, what's stacked on that, is we created for this project, because we had to do 126 MuleSoft integrations really fast, we have a facilitator app. This facilitator app is a wizard where someone can point and click, and it'll create a starter project. It makes all the cloud resources, and it creates your CI/CD pipelines. You're going to see a demo where May, who's 3 weeks out of school, she uses the wizard, and she does all this and manages to do meaningful work in about 15 minutes.
from the start screen, I just put in my user and Git token. Here we're going to select a release pipeline, which is this Git repository containing these config files. This will just go ahead. We have the option to choose the existing one, or we could create a new one from within Facilitator. Proceed with choosing a suite, which is this Git repository containing our code. And we'll be on the main branch. So now it's cloned both these repositories. I can start configuring my new project. We are going to build a function. On the screen, we set up basics like our Maven artifact ID. This goes into pom.xml, and it just names what the package is called. I'll call this something like query sf demo v52. For the base package, that'll just be the example com.coke-firm, and we'll add demo to the end. And at the end, I'll give this a description, something like demo 52 query Salesforce demo. And just now, it's generated our ARM template and our code. Here's zip files, which we can download to examine, but if we're happy, we can push them to Git. And we can spin up the Azure infrastructure. Awesome, and we are now done using Facilitator. I'll go into our Jenkins and refresh the screen. We have a demo 52 build target. So there we go. You can see I've implemented the convert input to request method very closely based on what's already there. We simply parse the body using the Jackson JSON mapper and return it as a hash map. We've updated the process body to call into our query result, our service method, which now returns the result as a list of hash maps. And this process body also handles stringifying the request result, the response body. Finally, we've overwritten some of our tracking methods here. Next, you can see that I've overwritten the service execute method so that we get the parameter query off of our JSON request, as well as our list of fields. And we call our myCoke.dao query method and loop through the results and convert them into hash maps to return. And finally, we've implemented the query method in the myCoke.dao so that it takes any arbitrary SOQL, which we're providing in our payload, querying Salesforce and returning all pages of results. And finally, moment of truth, getting our post to our new API endpoint with a SOQL query in the body, and we'll hit send. And there we go, there's our JSON response. These are the most recent 10 orders to myCoke Legacy UAT. And here's our transaction in the Firm console with our devlog and status success. So,
All right. So aside from a Mario star makes you go fast, right? You know, I hope you see that hey, she was able to point and click and create a starter project and resources and CI/CD pipelines, right? And able to do meaningful work really quickly, right? The other point to take away from this that is, Azure lets you point and click in your resources manually for all the various patterns that we had to support, that we support with our wizard. We pointed in, we clicked them in manually, we exported them, and we wrote string replacements, right? Other cloud providers don't do that, right? So that was great. No wasting time writing bicep, Terraform manually, right? So the next layer that we talked about was, a MuleSoft translator. And so I'll bring back to the demo we saw May do. And why is that important? Well, in May's demo, you'll see that it created a service class for her. It created DAO, and it created a function handler class in Java. And she wrote a few lines of code in a service class and in the DAO to make it work. Well, if you know anything about MuleSoft, this is a picture of MuleSoft XML, and trying to translate all that to Java, it's pretty hard, right? So we wrote a translator for that, and I'll show a demo of that.
And there's a lot of XML files in a MuleSoft application. The main one here is this delivery date XML. And the main flow that we're looking at that is called by the REST API is the delivery date flow. Okay, so how are we translating this into a service class? Well, there is a program we run, and I'll run it here, the generator. Okay, and it's done. It says build success. So let's look at what it made here. It made the delivery date service class, and the main flow is the delivery date flow. And you notice this takes something called a MuleSoft event, but this isn't a MuleSoft class. This is just a class that we made. So the question is, well, let's say it works. How do I integrate it? Well, how would you integrate it? This is the process method from the function handler. And there's a couple of lines or a few lines of boilerplate code to integrate it. So let's take a look at what it did. For the most part, it is a rote translation, kind of ugly-ish code, of what's in MuleSoft. There's this delivery date request mapper flow. You'll see the same things here. This method, I won't go into it. It reformats a payload, and then there's another flow here where we call Kona. Right. So what does this flow do? It calls another API in Kona, until it's successful. So let's go and look at that same in the Java code that was written. You'll see that, hey, we get a couple of config properties, right? We do a loop. The code creates another method. This method, ultimately calls Kona.
So I'll call Scott back in a minute. So in summary, what did we do? You saw the stacking of several things. You saw that we have Azure services, we have Firm, we have a Firm Facilitator app, and on top of that, MuleSoft. And this enabled us to move 126 integrations really fast. Scott.
Thanks, Scott. So there's really three takeaways. We had to develop our own framework because we realized at Coke, we had this 30 years of diverse legacy systems. We had an environment where we are a pretty lean engineering team. So we have to rely a lot on contractors. So kind of finding a way to develop, you saw with May, getting developers up to speed really quickly was essential for us to be able to meet the needs of our business. And second, kind of modern scalability also means adapting to hundreds of integrations and change. Like there are days when when there's a master data system that is sending 700,000 master data records and flooding our system, and we have to react to it pretty quickly, making these changes we couldn't find anywhere but to build our own framework. So, yeah, with that, I would love to hand it over to Tiago, who will tell us more about serverless in the Microsoft world.
Thank you. Thanks, everyone. Hello. The clicker. Thank you. Okay, I'm Thiago. I'm in the Azure Functions team. So let's dive a little bit deeper, have a look at some demos for Azure Functions. As Devanshi covered this slide before, I'm not going to go too deep into it, but basically these are the most common scenarios that we see people using Azure Functions for. If you go to our scenarios page online, you'll see that all of these are there, and they have links to repos and demos as well that you can have a look. The only one that I'm not going to show, I guess, is the web mobile APIs. That is a demo that I do so often, just showing an HTTP endpoint with a microservice built there and then scaling from there. But let's have a look at a few others, right? The idea behind this demo is overall smart retail solutions using Azure Functions. So let's start with the first one here, where imagine we have a large retail operation, and we have storerooms in the back where we have IoT sensors that are detecting when the stock of those products might start going down. Those sensors are sending events to Azure Event Hubs as basically a streaming service about all of those products and how the stock room is doing. And from Event Hubs, then we are triggering using Azure Functions. So that is constantly giving updates about each one of the products in the storeroom, and then from there, we update that inventory on Cosmos DB. So basically, we take batches of events. There's a stream of events about the products, and we take the last update for each of the products, and then we update Cosmos with the inventory for that store at that time, at that point in time. So let's see here how my computer's doing. Okay. Just log in again. All right. Oh, good. My local IP address is now on the Cosmos firewall, so I can actually access it. Cool. So let's have a look at what that first solution looks like. I have an inventory tracker C# function app here. And as you can see, it's triggering from Event Hubs. And then it sends out to Cosmos DB using the Cosmos DB output binding of Azure Functions. And basically what we're doing here, and I guess it's one of the key things, is when you're dealing with Event Hubs or streams of data, is to use arrays so that you get a few events at a time for you to process, right? And then you can either process them in parallel. In this case here, I'm just doing a loop between all of those events and then processing them to get the last update for this batch for each product into Cosmos as part of my Cosmos output binding. So I'll start my function here, just do a func start here on this command line and let it get started. And then I built with my friend Copilot, I built a very cool simulator here of IoT events, sending them into that event hub. So all of these are going into event hubs from my simulator. And then here, my function is processing all of those events in batches. If you're very quick, you can see that basically most of them are getting 100 events per execution of my function app. But that's just the default max batch size of event hubs on the trigger. You can definitely change that. I encourage you to play around with those values as well to see. We had a customer, or I guess an internal customer, GitHub, who they have been triggering from event hubs and then sending out via HTTP to a downstream logging system. And they played around with these values to increase the batch and find the right batch size that made sense for them to get the throughput that they wanted. They got up to 1.6 million events per second with their implementation, hosted on Azure Functions on the Flex Consumption hosting plan that we have out there at the moment. So that's the first one, basically from event hubs into Cosmos DB. Now, what do we do with this data that's in Cosmos, right? For this solution here, we have what is the next scenario, I guess, that I have in mind is reacting to changes in your database. This is another common one that we see through the change feed trigger of Cosmos. We have one for SQL as well. And what we're doing here is we are checking which stores has low inventory. I have in my code just a threshold there. And then for those that are, I kick off an orchestration with Azure Durable Functions. So that's basically 2 scenarios in one function here. One is change feed trigger, and the other is the workflows. Because basically, once I detect that a store has low inventory, I am going to start an orchestration that checks suppliers, might automate a purchase order, and then send a notification to the store manager that the product has been replenished. So that's the second part of this flow, is once that data is in Cosmos, then what do we do with it with that change feed and my workflow. So while I have this running here, let's find the inventory notification function app. Start. So I'm starting on a different port because the other one is already running, and the function host here needs its own ports to communicate. But I'll trigger this, and we can see here that this one has a few different functions in it. The first one is that inventory change trigger that is from Cosmos DB. It's right here. And it's basically checking in on updates going to Cosmos. And then in here, I check if it went over the threshold, and that is when I check to start a new instance of my orchestrator. So right here, schedule new orchestration async. I also have this running in the cloud, so that's going pretty fast up there. But I can show you what that looks like when I get those emails off the notification. So I put my name, my email address as the store manager here, but basically it's just telling me, oh look, we have a session now. It's just telling me, Smart Retail, there's a new purchase order created for us for Frostbite insulated jacket, and 25 units is going to be sent to that store, right? So that is the whole flow of these this first section of the demo. Cool. With me so far? Let's keep going then. The next one that you probably should have seen coming is dealing with purchase orders. And the service that we see the most customers using for once that there is a purchase order created is to go through Azure Service Bus, because it is a more advanced messaging solution where you can do quite a few advanced features with Service Bus. But in this case here, we're basically saving that purchase order to Cosmos as well on a different container, then checking the history of that customer's purchase order, and then using Azure OpenAI. Here's another scenario, right? Integrating with AI. And from there, sending a notification to the customer with, here's your purchase order, and here's an offer or a discount that Azure OpenAI has generated for us. So that's the flow for this one that integrates with that first part of our scenario as well, right? Purchase orders with OpenAI assisted recommendations. So let's have a quick peek at that. So here is where we have our order processing function app. And this one is a Python app. The other two were C#, but you can use multiple languages. You saw the guys from Coca-Cola talking about Java, and we support quite a few other ones as well as custom ones. And here we are triggering from Service Bus, and then we are generating personalized offers by going into Azure OpenAI. So I can kick this off as well. And as this starts, I have a separate simulator to generate those orders, which is over here. So this will basically start sending purchase orders. You probably see it's already processing a bunch of stuff there and sending them to Cosmos and checking into Cosmos as well. So this is basically using OpenAI behind the scenes as well to generate those recommendations. So let's have a look at here if I can find one. Here we go. So that's just one of the purchase orders that were sent. Oh, look, Frostbite, the one that was running low on inventory. That's why they bought 3. So here, this one, it tried to find that customer's history, didn't find one, so OpenAI just recommended, would love to find something special for you, feel free to browse, right? But there are some that would have, say, a specific amount depending on how much they bought and et cetera, then say enjoy your next 15% off your next purchase order. So that's this one where we start with a advanced messaging where each order needs to be processed and then going into the flow of that. All right. So while we're here, now that we've gone through these scenarios, I have here my resource group that has all what we need for these solutions to run, right? And as you can see here, I have quite a few networking related solutions, private endpoints, network interfaces, private DNS zones, and virtual network links. And that's because both Cosmos, in this anarchy, Cosmos and OpenAI, they're all behind a VNet that I have here, this VNet here. Of course, I could have put event hubs and service bus, but then it would be harder for me to send to them behind the VNet. But basically, my function apps, which are Azure Functions Flash Consumptions, they are virtual network integrated. So let me find one. Let's do the order one. And if I go to networking here, you see that it has a VNet integration attached. So that's how we can reach our Cosmos DB. For me to be able to run it locally, then I just went into Cosmos DB and added my local IP address to the exceptions, but otherwise you'd have to be inside the VNet to be able to reach that Cosmos. Sam knows about it. Okay, so with that, I think one other cool thing that I want to show for that first part of the demo where we have the higher scale event hubs is a couple of queries, or I could even go into, let's see, my event hubs here and just show the throughput. So I preloaded a lot of events before into event hubs, and if you know about event hubs, is basically if you have a cassette tape that you can rewind and each person is at a specific point that you can go back and forward. So that's how locally I have my function app running with its own checkpointing. And here on Azure, I have another function app that is the deployed version of that app that is processing that. So you can see here how it quickly catches up to all of those events that are coming in and processing them out. Another interesting view for that part of the demo is if I go to App Insights, I can have a look at some logs here. And this might work. So that's too long. Let me do 1 hour. So for the past hour, this is all of the runs that I've been doing just for testing here. You can see that at the beginning of a run, I go up to, say, 35,000 requests per second. This is binned by 1 second. So that's basically number of events per second that it handles. And then once it catches up, then it kind of stays within the simulator, how fast the simulator is going, right? But I've had some runs in the past here that show some larger scale as well. So you can see this one here. A few hours ago, it went to 60-something thousand requests per second. And another query that you can run is basically one that shows how many instances we're processing your solution. So I can do a timestamp bigger than 1 hour or 10 hours here. And have a look at this, and you can see that at some point it matched the number of partitions that Event Hubs had. Basically, Azure Functions, as it scales, it'll lock on. Eventually, it'll load balance to the number of partitions that your Event Hubs has. And each one of those is kind of latched onto a partition and processing as much as possible. This is an Event Hub standard, so the max is 32. When I created it, I chose 32 partitions. But say GitHub, for example, they had a custom one that had up to 1,000. And we saw their app scale up to 1,000. And then once it caught up, it kind of slowed down and partition the processing there. So let's move on to the next section here. I have 2 more scenarios to talk to you about, but if you want to have a look at the code for this solution, there's the QR code and also an aka.ms link that you can go to. I'm still finalizing a couple of things in there on the README and everything, but you can already go and check out the code for the demo. And 2 more interesting scenarios here. I mean, I find them interesting. Sometimes they might sound boring, but processing a blob that gets put into blob storage as fast as you want to or can is pretty consistently a solution that we see customers use Azure Functions for. So I could not involve this in this demo. Basically, what we do is when a blob gets put into blob storage, we have a source type of event grid, and that basically storage itself tells event grid that a blob was put there, and event grid starts our function app and executes it for that blob. And then function app picks up that blob and downloads it and or gives you a stream for you to process that blob. So we are basically taking this and this is a document that is a contract between this retail company and a supplier. And basically it's analyzing the contract, extracting information about the contract, summarizing it, and put that solution into Cosmos DB. So after we extract the info, we place them into Cosmos DB. So I can run this. Let me stop some of these guys. So there's too many things running at the same time here. And, oh, the Event Hubs is still going pretty crazy. There we go. So here is where I have that document processing one. I can run it locally here. And basically, if you've done some Azure Functions development locally, you would have probably done this before. For the other ones, I ran them using the command line tooling, FuncStart. But you can also use Visual Studio if you're developing in Windows with C#, or you can use VS Code to develop here, or Java tooling as well, IntelliJ and etc. But basically, I have a breakpoint here, and I have a local storage simulator here, basically Azurite that I started before. And I have created an existing container called uploaded documents, and I put a supplier contract in there. So the way that you debug this event grid sourced Azure Blob one is then from your local project here, after you start the debugging, you right click on process document and say execute function. So I'll just type in the name of the file, supplier.pdf, right? And as soon as I click enter, it executes my function and gives it that blob that is on my local storage emulator. And then here, of course, I can debug, walk the step through and see it contacting document intelligence and extracting information about my document and then saving it to Cosmos. So we could probably go to Cosmos DB here and just have a look at what one of those extracted documents. Now that my IP address is on the Cosmos firewall. So here's where I have some extracted documents. I'll just choose the first one here that comes up. It basically does some analysis. It knows the parties that are involved. So you can see here, Contoso Foods, Best for You Organics, key terms, the expiration date, obligations between the parties, and then a summary of it. So that's what the document is, the one that I uploaded and that are getting processed there. A standard, supplier contract, but I used OpenAI and Document Intelligence to extract this information and summarize it for me. And then finally, the very last scenario that people sleep on a lot is basically cron jobs, timer triggers. We see quite a lot of customers use this for batch processing, for example, when something has to happen on the weekend. And in this scenario here, we're basically taking all the products from Cosmos and checking if we should update the prices of those products based on purchase history, the industry changes, all of that stuff, right? But people also use it for policy checks, for example. We've seen quite a lot of folks that implement policy-related things, security-related checks as well, that has to, from time to time, just check if everything is according to the policies, for example. So that's the last one there. And if I show you just what the code looks like for it, it's, here we go, dynamic pricing. This is .NET 1. And it's interesting here, basically the timer trigger, I'm getting it from an app setting called schedule. And that app setting, locally I have it here, schedule, for every 30 minutes, I think, or 30 seconds. And up on Azure, on my deployed function app, I have it set to every 15 seconds. And with all of these, I just wanted to call out how the connections to storage, locally it's using my emulator, but on Azure, both to storage, to Cosmos, and all of the other services, I'm using managed identity to connect to it. So besides the networking bits that we talked about before, I really recommend trying as much as possible just to use managed identity between your function apps and your Azure services, because then there's no connection strings anywhere in your app settings or anywhere else, right? So here, let's just have a quick peek at one of those function apps, the timer one, which is this dynamic pricing. Oh, that's my managed identity. There it is. And like I said, all of these function apps are on the flex consumption plan. We just announced a 512 instance size, megabyte instance size for flex consumption. Basically, that if you are not doing any parallel processing of too many things at the same time where you need that bigger amount of memory or CPU or resources, then it makes more sense to use a smaller instance size like the 512 one and let it scale out for the number of events that you have, because you're basically paying for that 512 while your instances are active instead of 2 gigs, for example, in this case here. But because we're doing bulk updates, it's I left it at the 2 gig size. Like I mentioned before, this is set to run every 15 minutes, and I'll just open one of them here to see the logs. But basically, it found 100 products to analyze, and then it's going through each one of those products to see if there's any that should have their prices increased. Cool. So the last thing I wanted to call out for flex consumption, at least, is we've announced a whole lot of new regions that flex consumption is now available. Especially West Europe is one that we heard a lot from when we went GA in November last year, so we're happy to finally have it there. And also availability zones is in preview, so the 512 megabyte instance in availability zones is in preview. We hope not to leave it in preview for too long, and then GA is soon. So looking forward to your feedback from all of those. All right, so quite a lot. Again, that link is the same repo as the previous one. And just in summary, I guess, overall, from me and the team that presented today, Azure Functions is one of the best services for event-driven solutions. There's quite a lot of scenarios you can cover with it. It's trusted by over 500,000 customers, including Coca-Cola that you heard from today. Flash consumption is GA serverless hosting plan, does very fast scaling. It can handle high load and includes networking security with VNet integration, private endpoint support. And then you can, like you saw, with my demo and with the demos from the Coca-Cola team, you can combine Azure Functions with other event-driven or integration services to implement your best architectures. And with that, we still have 8 minutes to go. Happy to take questions. But also the team will be just outside the room. We have some of the engineers from the team and other PMs as well that we can answer any questions, or if you have questions, for the Coca-Cola team, they're happy to help there too. But just so that you can check here, we have some related sessions. Agentic AI inferencing with Azure Container Apps. We have AI agents with MCP and Azure Functions, which is a lab. They're running another one on Wednesday. So they did one today, another one on Wednesday. But with that, I think that's us. Let me know if you have any questions. Happy to answer.